Good morning to all. In the previous session, just we concluded how to find the Fourier series of waveforms. Now in this session, now we are going to start another topic, that is exponential Fourier series. In the previous case, we did trigonometric Fourier series. In this session, we are going to start exponential Fourier series. Now just look at. Now just look at. In the previous case, in the previous sessions, we discussed trigonometric Fourier series. This is over. Now we are going to discuss exponential Fourier series. We are going to discuss exponential Fourier series. Now just look at. An exponential Fourier series of a signal x of t. It can be written as summation n equal to minus infinity to infinity f of n into e power j n omega naught t. This is the main equation. Minus infinity to infinity. So here just look at. No need to write n equal to minus infinity to infinity. Whatever there is a suffix, generally it belongs to that suffix in general. If you have any doubt, you can make it n equal to minus infinity to infinity also. This is the Fourier series of an exponential signal where signal. For this signal, what is the interval? Interval, that means period, is equal to t naught plus t naught plus t. That is the interval. Period of this signal. Now, where what is this constant f of n? This constant f of n is equal to total width, that equal to 1 by t integral t naught to t naught plus t. What are the signal it is given? X of t into e power. There positive is given. Here you have to make it negative. N omega naught t into dt. No need to have any such type of confusions. This is the Fourier series, exponential Fourier series of any signal. It can be written like this, exponential series. Okay, here f of n is the coefficient. It is the total highest limit minus lowest limit, not like that. That is 1 by t from 0 to this one. F of n means what? For whatever the signal, we are finding the signal into, here it was in the main equation, it was positive. Here you are supposed to make it negative. Understanding? Now, this is the exponential series, trigonometric series. Now just look at. The next topic is relation between, what is this one? Relation between trigonometric and exponential series of Fourier series. Very important. Relation between trigonometric Fourier series and exponential Fourier series. Trigonometric Fourier series means what? Half a naught summation 1 to infinity an cos n omega naught t plus bn sin n omega naught t. That is equal to what we got? Summation minus infinity to infinity f of n e power j n omega naught t. This is the relation. Both are same. Here one more point. N belongs to 0 plus or minus 1 plus or minus 2, like that. For all integers it covers. All integers it covers. Here, especially for this one. But for here, n equal to positive values, n to infinity. But here, n is equal to 0 plus or minus 1 plus or minus 2 plus or minus 3, like that. Now just look at, you expand this one. Right hand side you expand. First you take 0. 0 means what you get? f naught into e power n equal to 0, e power 0 equal to 1, that is equal to 1, plus next one, put n equal to 1, that is equal to f of 1 into e power, here n equal to 1 means what? Here e power n means what? N equal to 1, that means e power j omega naught, e power I theta, Euler's formula. So this will become cos omega naught t, n equal to 1, omega naught t plus j sin omega naught t. Next one, plus f2, n equal to 2, f2 of cos 2 omega naught t plus j sin 2 omega naught t. In this way, all positive values will go on. But here, n takes what? Not only plus 1, plus 2, plus 3, plus 4, but also takes minus 1, minus 2, minus 3 also. In the beginning, we already substituted the value of 0. So, f naught we got. Now, just in place of this one, we have to substitute minus 1, minus 2, minus 3 like that. No need to substitute each and every value. For understanding purpose, first two terms just we are substituting. Now, in this extension, plus n equal to minus 1. So, this is minus 1 of, look at, minus 1, suffix minus 1. Here you keep minus 1, e power minus I theta. That equal to what? Cos omega naught t minus j sin n omega naught t. Next one, put substitute 2, suffix equal to 2, minus 2 of, now just look at minus 2. Here you can make it minus 2, e power minus I theta. That means you get cos 2 omega naught t minus j sin 2 omega naught t plus etc. The series continues like this. So students have to understand that. Look at n equal to, n takes 0, all positive integers plus 1, plus 2, plus 3, and also takes all negative integers minus 1, minus 2, minus 3, minus 1, minus 2, minus 3, all integer values it takes including 0. So for 0, this is for 0, this is for 1, this is for value 2 in this way. After that, you have to substitute negative integers, f of minus 1, this is for f of minus 2, plus etc. etc. No need to go for more than 2 terms, time waste. Understanding all these one. Now just look at here, keep all same terms into groups. F naught is individual. F naught is individual. There, first look at, in the f minus 1, cos omega naught same. Here, cos omega naught is same. So, if you take cos omega naught, this is equal to f naught plus, if you take cos omega naught t, then you can make common as f1 plus f minus 1. Now, just look at, I am highlighting the coefficients of f, that means exponential trigonometric series. In this way, just you can make it all terms, homogeneous terms like this only. Okay. After that, equating or comparing, not equating or comparing. In this way, just you can make it like this. Now, comparing equal terms, comparing equal terms both sides, comparing equal terms both sides, we have, now just look at, we have A naught is equal to F naught. In the left side, how many coefficients do we have in trigonometric series? A naught, An, Bn. A naught, An and Bn only. But here it seems to be so many number of coefficients upon the expanding this series. But after concising coefficients of equal terms, now just we are going to get A naught equal to F naught. Similarly, An value is equal to Fn plus F minus n. Bn value equal to complex number of Fn minus F of minus n. Now just look at these three are representing the relation between trigonometric Fourier series and exponential Fourier series. Very, very important. For 2 marks questions in the examination, they ask you 3 questions. Write the representations of the relation between trigonometric Fourier series and exponential Fourier series. Here it is sufficient to write like that. But for example, just look at, you know A naught equal to N1. If n equal to 1, then what happens? A1 equal to F1 plus F minus 1. If n equal to 2, what happens? A2 is equal to F2 plus F minus 2, etc. In this way it continues. Now the same n equal to 1, same n equal to 2 should also be applied for Bn or not? Yes, we have to apply. In this case, applying the same here, now you can write B1 equal to complex number of F of 1 minus F of minus 1. For the same n equal to 2, it will become suffix B2, that is equal to complex number of, this becomes F of 2 minus F of minus 2, etc. etc. Now just look at, these are the relations between trigonometric Fourier series and exponential Fourier series. Students have to remember one important point. First, exponential Fourier series. Exponential Fourier series can be represented in this way. Summation minus infinity to infinity f of n e power, look at the sign, this is positive n omega naught between the given interval time period, where this constant f of n equal to this much. So here what we are doing, the relation between trigonometric exponential series means we are comparing coefficients on both sides. Look at, there are no sin n omega naught t or cos n omega naught t. You could see no terms like that, no trigonometric series. Here, just here also trigonometric series missing, here also missing. Just look at, upon comparing these two left hand side, right hand side terms, just we are able to gather the coefficients of a naught, a n, b n. Understanding? This is comparison. Comparison means what? Comparing. Comparison means what? Comparing sin n omega naught t, sin 2 n omega naught t, similarly cos n omega naught t terms. This is called comparison. This is called comparison. Upon comparing sin omega naught t, cos omega naught t terms, we are going to get these relations. These relations are important. Whenever in examination, generally this representation is important. Generally it will be asking for 2 marks or 3 marks like that. If it were given 5 marks, now just you are supposed to make this much. That is the representation of exponential Fourier series, and this is the relation between trigonometric and exponential Fourier series. Representation, remember, a naught equal to f naught, a n equal to fn plus f minus n. For bn, keep imaginary numbers. That imaginary number is for sine terms. Without imaginary number, pure one are for cosine terms. Now just look at, this is the way. For example, n equal to 4 means what? For example, n equal to 4. That means what? a4 equal to f4 plus f minus 4. Similarly, b4 equal to f4 minus f of minus 4. In this way, just you are supposed to substitute the values in the suffixes of this one. This is very important relation between these two. Okay, thank you.